Welcome everyone, my name is Faulkner. I'm the online event coordinator for Staff Development for Educators, and I'd like to thank you for joining us today for Foundations of Number Sense, grades K through 1st, with Ricky Mikelman. Before we start, there are a few things you should know. To allow for Ricky to be heard clearly, the attendee microphones are muted. Please use the questions text box on your screen throughout the webinar to ask any questions. I will throw those to Ricky as we go. Most audio and video problems you might experience during the presentation can usually be solved by closing other programs and applications you might have open on your computer. This session is being recorded, and assuming no technical difficulties, you'll receive a link to the archive within 48 hours. And finally, at the end of today's presentation, you'll see a short survey, and by completing that, you do assist us in providing future complimentary webinars. For those who might not know us, Staff Development for Educators provides professional development for pre-K through 12 educators through on-site PD, PD events, web-based PD, and PD resources. We empower educators with research-based, innovative, and rigorous PD that's practical, motivating, and fun. We're pleased to have our good friend Ricky Mikelman joining us today. Ricky has spent 30 years in education as a classroom teacher and math coach. She's been active in curriculum writing and district-wide staff development, but teaching is her passion. While researching additional teaching methods, she discovered how well Singapore math helped students struggling in math. Her passion for teaching shines through in her energetic and humorous presentations. Ricky recently authored the Math Coaching Tool, a series of questions, stems, and activities to help you engage students in all 8 of the mathematical practices. Welcome, Ricky. At this point, I'm going to turn it on over to you.
Hello, everybody. Welcome. We're going to be talking about number sense with our kindergarten and first graders. And this is so important because our little guys seem to know exactly what's going on. They come into school so proud of themselves that they can count to 100, that they know 6 and 6 is 12 and 100 plus 100 is 200. In first grade, they can tell us that 43 is 4 tens and 3 ones. But we like to call these an illusion of learning because when we dig any deeper, we find that they have this really nice surface level learning, but they haven't gone deep. And it's one of our challenges as K-1 teachers to teach with depth in ways that keep us and our students interested. So first I want to talk about how numbers are used because we need to make sure that we are teaching all these different ways with number sense. So rote counting, that mother comes in with, Johnny can count from 1 to 100. And that teacher filter that keeps you from swearing, keeps you from saying big whoop. Because I could probably teach a monkey to count to 100. And counting to 100 rote is almost like elemento. So we want to know that, yes, it's important they count. If I'm assessing children, I assess them up to counting to about somewhere between 32 to 36. I want to make sure they have the pattern going, and then I have them count by tens to see if they have that. If your district has an assessment, I suggest you train 5th graders to come down and listen to your kids count to 100. The next kind of counting is rational counting. This is counting with one-to-one correspondence. And we want to make sure our children have this one-to-one correspondence because they really can't move much farther until they have that. When we look at our little guys, things look great until they get to about 13. So I put objects down, and I'll put a fairly large pile, and I have them count again into their mid-30s. And then I watch how they count. So not only is the sequence correct, but how are they organizing? Are they touching as they count? That's a pretty basic level. Are they organizing them into a line or moving them from one pile to another? That's a higher level. The highest level, and where we want to make sure our first graders are when they count, is that they are grouping them by 5s and 10s so that they're starting to get the beginnings of place value and using a system that's going to take them farther as their numbers get larger. So if I'm counting people sitting at a table, I would see that there are 4 people at a table. And then as I look at the next table, I see that there's 3 more there. Now, if I have cardinality, I can hold that 4 in my head and count on 5, 6, 7. So that cardinals, how many are in a set? When I count 1, 2, 3, 4 people at the table, it's holding that 4 as in a table. That shows me I have cardinality. I'm going to go to subitizing and then go back to that slide. Subitizing is when you look at a number and a collection, and you recognize it without counting. So as I look at my dots, in all examples, I can see 6 dots. In the first one, I can see 6 right away, that I can see the whole 6. Generally, children can subitize in kindergarten and first grade. They should be able to subitize dice patterns. They should be able to subitize a 10-frame pattern up to 10. And they should be able to subitize the dominoes up to 6. Once we get past 6, then we start seeing groups and putting them together. So the third example here clearly shows, oh, I see 5 and 1 make 6. 4 and 2 make 6. One of my favorite activities when I taught kindergarten was the kids would make subitizing plates. So I would put the cheapest plain white plastic plates into the learning center, and I would put bingo daubers, which are like little paint spotter things, and the kids would have to subitize, would have to make whatever number we'd said using only 2 colors. And then when we came to circle time the next day, I could use those plates and flash them at the kids to see if they could subitize the numbers. Ordinal numbers are position, first, second, third, fourth, and they've actually been taken out of the Common Core in kindergarten and first grade. But I'll tell you, it's still really important that you are teaching ordinal numbers and that you are using ordinal numbers, because when they get to fraction, they need to understand them, and they need to understand what's 4 and fourth and how are those different. So even though it's out, you can still throw it in a workstation every once in a while or do a fun activity. Measurement is it's just measuring. What time is it? How many pounds do you weigh? How far is it to school? And our children need to understand that there are different units of measurement, and they're going to get different answers depending on the unit of measurement they use. Nominal numbers are numbers that name or identify. Now, this would be your phone number, your social security, your address, that they have nothing to do with counting, that they're just an identification. The last way we use numbers, and it should be the most important way you're using numbers is in your classroom, is in real life situation and in problem solving, so the children can see that the math we're doing makes sense. All right, questions about how numbers are used?
Nothing's come in yet, Ricky.
All right, then I'm going to keep going. One of the hardest things in doing this in a half an hour was choosing what to do. So I've kind of just chosen a few basic things, and I can suggest lots of resources if you want more information. So the first thing we're going to talk about is number bonds. Number bonds are part-whole thinking that help our kids decompose and compose numbers. I know that when I work with upper grade children who are struggling, what they have the most problem with is this part-whole thinking. And this is one of the keys that you're doing in your classroom, K-1. So our kids are seeing these inverse relationships. Instead of me saying this is a fact family and teaching it, when I teach it as a number bond, the children see the whole and the parts. Also, I want to make sure that children understand that 5 is 3 and 2 if I write it that way or if I write it that way. Faulkner, did that show up on your screen as I wrote?
Yes, it did.
Oh, perfect. So that, and our children are developing algebraic thinking. If I say 5 is 3 and what? If they say 2, that's algebra in our youngest grades. So this part-whole thinking is very important. Now, you might call it number bonds. You might just call it decomposing numbers. The name isn't as important as the concepts, and there are so many fun ways to teach this. I especially like using Zoopow plates, but always when we're teaching our concepts to children of any age, not just our young learners, we want to make sure we're teaching concrete, pictorial, abstract. So let me show an example of, we'll talk about this and I'll show an example of that later. This number strip is from Building Number Sense by Catherine Kuhns, Kuhns. And if you have a question about the names of books, if you just type out that question, I'll put it in the Q&A and you can see it. So this comes from the back of Building Number Sense. And I'm going to look at these flamingos. And first, the kids have to talk about how they're going to sort them. So the kids might say, well, I could sort them into either they have an attribute or they don't. That's the most basic category. So either they have head feathers or they don't. They have tail feathers or they don't. They're eating or they're not eating. One of my favorites came from a little kinder, and she said they have pedicures or they don't. So that's one way to count it. Now, a little bit more sophisticated would be to put it into one of two groups. So either they're pink or they're yellow. They're tall or they're short. So it just takes it up that little notch. So let's count our flamingos by color. I'm going to say that there are 8 flamingos. 8 is my whole. And the parts of 8, I see 5 yellow and I see 3 pink. The parts of 8 are 5 and 3. Now from here, as I want my students to write number sentences, I want them to do it language-based. I want to make sure they can tell stories. So the children might say, there were 5 yellow birds and 3 more pink birds came. How many birds are there altogether? Or there were 3 pink birds and 5 more birds came. How many birds does that make altogether? So the children are starting to see the relationship between this number. Now, when I do subtraction, I know lots of teachers are guilty of saying, put the big number first. Well, when they put the big number first, they get to second grade and they see this problem and they go 5 minus 1 is 4 because they put the big number first. So I always say put the whole first. There were 8 flamingos and the 3 pink ones ran away. How many yellow ones are left? Or I could say there were 8 flamingos and I took away the 5 yellow ones. So how many penguins does that make? So here I've done my whole fact family. Now you'll notice sometimes I use symbols and sometimes I use words. You want to make sure you're using the child's natural language first, so that the children are very comfortable with the concept, and then we introduce the formal language. When we're teaching vocabulary, and I see this in most language arts, but also in most English language learner, they always say you've got to teach vocabulary first. And I did a lot of research on this, and the reason that is when we're teaching it in language, it's usually because we're translating it. But in math, when we're teaching the concept, we want to make sure we teach the concept first and then gradually add the formal language so that children have a full sense of the language. I think in the U.S., and fortunately it doesn't apply to K-1, the vocabulary is more important because of testing. if you're in a public school. But I always want to start with their natural language. I love this. This is a picture I took in Singapore, and we talk about decomposing numbers. Well, let's decompose words so the children understand the relationship. We want to bring a lot of our best language arts strategies into math. This is another picture from Singapore, and this is a great example of spiraling. Now, we talk about Singapore math, but the truth is Singapore math is the same as your state standards. Whether you have Common Core or a version of Common Core, or if you're in Texas, the TEKS, they all have standards. And we keep saying Singapore math, but Singapore math looked at the best research of the world to develop their math program. Our standards in the U.S. have looked at Singapore because they've already done a lot of the legwork. So it's really the same as standards-based math. So I want to spiral my curriculum. I want to make sure I'm always building on what children know. Marzano teaches us that the best indicator of what a child will learn is what they already know. So if my children understand 4 and 0 make 4, when I come back to this the next time, I'm going to say, well, you know, for the word and, I'm going to use the word plus. And the math word for make is equal. Equal doesn't mean the answer's coming next. Equal means what's on one side of the equation is on the other side. Oops, I think I'm going to write the word equal. Sorry, I got ahead of myself. The next time they see this, I'm going to spiral. I'm going to add a little bit of new knowledge. I'm going to say, in math, we don't have to write the whole word plus. We have a symbol, and it means plus. And we have a symbol for equal. And that's how we spiral our curriculum. And we want to make sure sometimes we put the whole first, even in an addition problem. So I'm going to keep on with my part-whole thinking with one of my favorite manipulative number bracelets. And on the SDE website, and I'm sure Faulkner can add a link to this, there's a whole handout on all different kinds of things you can do. But I'm going to say that I want to teach my kids to add with number bracelets. So I'm going to say to them, I have 7 plus 5. And I tell them to get 10 in their hands, so they actually wrap their hands around those beads. I think I'm going to write this out. So they have 7 plus 5. But the children, to make 10, they decompose that 7. 5 and 5, that makes 10. And the parts of 7 are 5 and 2. So 2 plus 10 equals 12. All right, let me erase this so that I can bring it out on the really nicely. So when I write it like this, that's considered pictorial. In the beginning, while the children are working, first we just do concrete. Then I start to write and they watch. And pretty soon I add them to recording their thinking. Now, people have said to me, wait a minute, that looks abstract, it's numbers. But it's still considered pictorial because it's a picture of your thinking. From there, the kids are going to go to abstract. They're going to go to their number sentence so that they're seeing the relationship of these things. When we talk about teaching concrete, pictorial, abstract, this is what it looks like in our K-1 classroom. I might even take this to place value, which is another form of abstract, where we talk about how many 10s we built and how many 1s we have left. Any questions?
We have some questions, but I think they probably can hold till the end, actually.
All right. Now, also, the most commonly used manipulative in Singapore in first grade is the 10 frame. Kindergarten, you're probably starting with a 5 frame, and then you move up to 10. Well, let's say I have here 8 plus 5. My kids can see that, oh, it's so much easier if I fill my 10 frame first. So I have 8 plus 5. If I just put 2 in that 10 frame, it fills the 10 frame. And 3 of them are hanging out there loose. So there's my 10. My new number sentence is 10 plus 3. Now, for some of my kids, this is a lot of writing. So I don't write this 3 here. I just put 10 plus 3 up there. For some of my kids, I found they were going 10 plus 3, and they were also adding in this 3. So for those kids, when I use those numbers, I cross them out. And that helps the kids. So there's always tweaks you're going to have to make to fit your kids in your class. Missing addend is one of the hardest things for our little guys to learn, and it's because they don't have their part whole thinking. If I say, oh, my whole is 10, I have 2, how much more do I need? Well, there's my whole first with the equal sign. Often your kids will say, Miss Mikelman, you made a mistake. You can't put the equals first. So you want to make sure that you do it both ways. So 10 equals 2 plus something. Teach your parents that when we say we're teaching algebra to our young learners, that that's what it looks like. From there, I might write it as a number bond. Or I could even take it to algebra by doing a number bond to a part whole card to a blank. And don't do this in K-1, but here's where it's going, is that's the X. That's exactly where we're leading. Here, I love this picture. I took this in New York. This is a teacher made double 10 frames and she put them up on her smartboard. She made them on a shower curtain, so they were easy to fold and put away and to take out. And she has Velcro behind these dots, so the kids can really manipulate them. You'll notice it's at a very child-friendly level, so the kids can reach it. We want to make sure we put our manipulatives down where they can get them. There is an order that we use manipulatives. This comes from the work of Zoltan Dienes. And Zoltan Dienes is actually the inventor of base 10 blocks. What he teaches us is we need to use lots of different manipulatives to build understanding. When I taught kindergarten, I loved it because if I put out the same old workstation with different manipulatives, the kids were so excited it looked brand new to them. So we want to start with manipulatives that are everyday materials, that are proportional, and that I can bundle and unbundle. I can take them apart. So it might be something as simple as a chain of paper clips. It might be bundles and leftovers. This shows popsicle sticks, but quite honestly, the flat coffee stirrers you get at your favorite coffee house are much better. I used to use the round straws when I taught. They were nice because they were light, but they rolled all over the table. And instead of bundling with rubber bands, I like to bundle with a chenille stem, a pipe cleaner, because the kids can bundle and unbundle that. The other thing that would fit into this group would be Unifix cubes, because they can take them apart and put them back together. When they understand that, then we can move to manipulatives that are already bundled. First grade, I really highly suggest you make bean sticks that you get. I like, instead of popsicle sticks, I like the tongue depressor or craft stick size. Then I have my kids put their 10 beans in a 10 frame. Otherwise, I found that I had 7 sticks and 22 sticks, and Johnny made a pattern stick. So I make sure it's nice and clean. And the kids can see that I have to trade in a 10 for 10 ones. It's the beginning of regrouping. So I want to start with everyday materials, but then I can move to things that are manufactured. From there, you go to non-proportional. And K-1, you're probably not doing much non-proportional because it doesn't make sense to your kids. This is materials where a 10 is the same size as a 1. Think dimes and pennies. That's the manipulative your kids have at home, by the way, if you're working on your 10s and 1s. Okay, I'm going to take a breath and see, Faulkner, do you have any questions for me?
We do have some questions not necessarily related to manipulatives and everything, but do you want to just jump into them?
We can, or we can do addition and get the questions afterwards.
Let's go through that.
Okay. Oh, I have one more picture. I love this. This is from a Spring Branch classroom. Also, this is at a very child-friendly height. You can see there's feet going through that window. The teachers have the numeral. They have it in written form. They have it in dots. So there's their dice pattern. They have their fingers. They have a 10 frame, and they have all the possible ways to make it. I just took this picture, so they're only up to 3. All right. So you've taught addition with your manipulatives because we always want to do concrete first. Now we're going to go to abstract. And the first thing I want to do is something I do not do with children, but I'm going to lead you through this. We're going to add, and obviously I don't do this with K-1, we're going to add 1,568 plus 2,748. I'm going to start in my hundreds place. 500 and 700 is 1,200. It doesn't matter what order I go in, but it sure matters how I say it. I think I'll do my ones. 8 and 8, 16. Oh, let's do our thousands. 1,000 plus 2,000 is 3,000. And now I still need to do my tens. I can either say 60 plus 40 is 100, or 610 plus 4 tens. I prefer to say 60 plus 40 is 100. Now, for all of you who grew up with do the ones first, do the ones first, do the ones first, the reason I do this is to show you it doesn't matter what order you do it. This is called partial sums. And this is the first step you should be taking before you are regrouping with carrying that 1 over here. So let's look at the second problem, and I'm going to show it 2 ways. If your parents are a little leery of this, I suggest that you make a video of this. If you have a smart recorder, make a video of this and put it up on your smart board, or let children do it and put it up on a smart board so parents can learn what you're doing. So if I add 6 plus 7, well, if I was using my manipulatives, I could either record it as 6 plus 7 is 13, 20 plus 30 is 50, and then I could add it all together. And once my children have firm understanding of this, then I'm going to say, you know, that's a lot of writing. I'm going to be more efficient. I try not to say I'm taking shortcuts. I just say I'm being more efficient. 6 plus 7 is 13, and I know that my 3 goes here, but I'm going to put that 10 in the tens place. I don't say carry the 1 because that's not a 1, it's a 10. Then I can say 1 10 plus 2 tens plus 3 tens is 63. Something you're going to start seeing in the future, some of you are already seeing it, is when you regroup that 10 that they're putting it down there on that line. And that's because they're concerned that children can confuse this for the number 12. All right. Faulkner, that's as far as I was planning to go, so I'm ready to take any questions that people may have.
Okay. Deborah was wondering, what would your expectation be for preschoolers as far as number recognition, rote counting, or one-to-one correspondence?
Your children should come in, even in pre-K, knowing their numbers to 3. And in pre-K, I want to make sure they understand all the combinations, all those number bonds to 5, that they have those solid. However, most pre-Kers can easily go to 10, and many of them can go to 20. I would say look at your state standards. I believe for pre-K the kids are counting to 20, but they're only really manipulating their numbers to 5. But if they are ready to go to 10 with deep understanding, go ahead and take them.
Okay, we had another question. If you had suggestions for books and authors on Singapore math, and I'm thinking maybe that would be good. What we can do is add that into the Q&A.
Yes, that'd be. I'll put that in the Q&A. I have several suggestions.
Okay.
So I will be happy to answer that there.
Excellent. And we did have actually a question where someone was asking if you could explain something in the Q&A, so I'll leave it for that. And the last one was kind of along with the addition and subtraction here, but what is the easiest way to introduce addition and subtraction to kindergarten?
You you always want to be concrete. You want to make sure they're using manipulatives, and you want to be putting it in context. So if you tell your kids that there are going to be 10 kids in line, 8 of them are already there, how many are coming? The kids are, that's going to make a lot more sense to the kids than if you say, okay, I want 10, I have 8, how many more? That's more confusing. But if you're using manipulatives, if you're using your Unifix cubes or linker cubes or whatever you call those cubes, if you're using your 10 frames so the children have a visual, if you're playing a game like Bullwinkle where the kids are doing it up on top of their head, and Faulkner, maybe we can even embed a picture of that. Your children, it's going to be making sense. So the more stories you tell, the more sense it's going to be making to your students and the more easily they'll grasp it. Kindergarten, you want to make sure your kids leave your grade with solid understanding of all the number combinations to 10 with a huge emphasis on 10. It is so much easier for our little guys to count on. Take 6, hold it in your head. Seen kids almost give themselves a concussion holding it in their head. And then they count on 7, 8, 9. Well, that's a great strategy for our pre-K and our 1. It's a valid strategy, but it's also a dead-end strategy. Because if I've got 37 plus 26, it's 37, hold it in your head, 38, 39, 40. It's not going to work. So they really need to have strong understanding of that 10 and make that one of your primary goals for this year.
Thanks, Ricky. And what I'm going to do right now is spend a minute or so, let anybody who might have come up with some questions for Ricky get those submitted now, because we'll add those to the Q&A that we'll include on the SDE website along with the archive. And in the meantime, to thank you for attending today's webinar, I would like to offer you a 10% discount off SDE PD events or on-site training by using the promo code W101116 before November 11th. You might be interested in saving 10% and attending SDE's two-day guided math seminar. It's being held November 14th through 15th in Elk Grove Village, Illinois, on December 1st and 2nd in Ontario, California, in Raleigh, North Carolina, January 12th and 13th, and in Houston, Texas, January 23rd and 24th. And do keep in mind that with the paid registration of a staff member, a principal from the same building can attend the same number of days tuition-free, so that your principal can also learn a little something about number bonds. And of course, if you can't make it to a seminar or conference, SDE is ready to provide customized training to your school or district. Just give us a call at 877-388-2054 or visit us at sde.com. And please do follow us on social media, Facebook, Twitter, and Pinterest under the username SDE4Educators with the number 4. And so it looks like we were able to get a few more questions in there, Ricky. And what we will do, as I said, we'll post the full Q&A. I'll ship those off to Ricky, and she'll get those back to me as quickly as we can. And hopefully we'll have those up on the SDE site pretty quickly, along with the webinar archive. But we will be sending everybody who attended in about 2 days. You'll get a link to the archive along with a reminder about the code. So Ricky, I want to thank you for joining us today. I hope everybody enjoyed today's presentation and that everybody has a great rest of the day and week. Goodbye, everybody. Thanks.
Thanks. Bye.